So step number 1, isolate the radical. Isolate the radical. Step number 2, square both sides. Square both sides. Step 3, isolate the variable. And step 4, grabbing my red pen. You must, and I'm going to underline must a bunch of times, so you know that it's really, really, really important. You must check your answer. So way back in grade 9 when you saw linear equations, we're like, check your answer, and you substitute in, you make sure the two sides are the same, and yep, was always the same. There's a whole bunch of equations now that you're just meeting that are called special equations. Radicals are the first type of special equations. You'll meet 2 more this year, and you'll meet the last one next year. Special equations are sometimes when you check the answer, it doesn't work. And so if you skip out that step, you're going to think you have an answer, but when you go to check it, it actually doesn't work. So you have to check your answer with special equations. How do you check? Substitute into the original equation. And solve each side. Substitute into the original equation and solve each side. If they're the same number, good to go. If they're not the same number, not good to go. So I'm going to put an asterisk up here and tell you this is a special equation. There are 4 types. Again, you'll meet the other 2 later on in this unit. You'll meet the last one in grade 12. Linear, not so special. So the first example we're going to do right on this sheet so we can have it right beside the method, and then we'll flip to paper for the last ones. So step number 1, we need to isolate the radical. What that means is I need this root of x all by itself. How do I get rid of a multiplication by 3? Divide by 3. Okay, so on the left I'm left with root of x, which is what I want. On the right-hand side I'm left with 2. Okay, that's step number 1, isolate the radical. Get the radical all by itself. Step 2, we want to square both sides. That's because right now I'm square rooting x, and what's the opposite of square rooting something? Squaring. And what I do to one side, I've got to do to the other side. What happens to the square root of x if I square it? It's just left with x, and that's the purpose of why we're doing this. And I'm just going to simplify up the right side, 2 squared. Isolate the variable. Done. Last step. Check. So we go back to the original question. I'm going to take out x, I'm going to put in 4, and I'm going to leave everything else where it is. Now when you check, you can't start moving stuff from side to side. That's solving. Check is you work the left till you get a number, you work the right till you get a number, you hope they're the same. This is bed mass, so what comes first? The square root. Why does the square root come first in bed mass? It's the same as an exponent, so it's the e in bed mass. So I'm going to leave the 3. I'm going to do the square root of 4, which is 2. Then the multiplication, 6 times, oh, shoot, just told you the answer. 3 times 2? 6 equals 6. What does that tell us? It's right. The answer is 4. And I'm going to show you in the examples later on what happens when they're not the same. There's a radical equation. Love solving equations. There's something satisfying about getting that value. Okay, grab paper if you haven't already. Same title, Solving Radical Equations. What's nice about these steps is they're not going to change. There's no exceptions. It's always going to be these 4 steps. Step number 1 is isolate the radical. So for visual people, sometimes it helps just to highlight where the radical is because it means everything else has to be stripped away. We need to get rid of the 4. We need to get rid of the minus 5. What's the opposite of subtracting 5? Adding 5. So I'm going to add 5 to both sides. And that means the right-hand side turns into 8. What's the opposite of timesing something by 4? Dividing by 4. So that leaves me radical x plus 1. And the other side ends up being 2. Okay, that's step 1. Radical is by itself. Step 2, how do we get rid of the square root? Square both sides. On the left, the squaring takes rid of the radical, so I have an x plus 1 left. The other side, 2 squared like last time, is 4. Here's where we have step number 3 that we did in the last one, is we just need to isolate x. So how do I get rid of that plus 1? Minus 1, so x equals 3. Well, we don't know yet if x equals 3. Maybe it equals 3. That's a special equation, is we don't know till we actually go back and check. So go back to the original, take out x, put in the value, leave everything else where it is. That's a 4, not an h. Now, for BEDMAS purposes, mathematicians get really lazy with square roots, and we need to assume there's actually brackets under there. Your calculator does it. It's just we get lazy when we write them. So with BEDMAS, that's where you're going to go first, is under that root, because there's imaginary brackets. So I'm going to do that first, which is 3 plus 1, 4. After brackets is exponent, so that's the square root. What's the square root of 4? After exponent is division, don't have anything. After division, multiplication, so the 4 times 2. And finishing it off, 8 minus 5. And what does that tell you if 3 equals 3? Then we got it right. X equal 3 is the answer.
Okay, now I feel like I should know this, but when we actually were solving it, before we checked it, how did we get the x plus 1 equals 4?
So we square rooted or we squared this side, and the square and the cancel and the root cancel.
Oh yeah.
And this is just a 2 to the 2.
Or no, wait. I meant the 4x4. I meant the 4 root x4 equals 8.
This step. What's the opposite of subtracting 5?
Adding?
Adding. So 3 plus 5 is 8.
Okay, and then we got to it by dividing by 5.
Correct.
Oh.
Yeah, and I'm just skipping a few of those steps, but if you want to show them, you can show them. There's nothing wrong with that.
Okay, my bad.
How are we feeling so far? These aren't bad. Like, these look really hard when you first look at them. You're like, wow, I'm really smart.
Yeah, they're a little scary.
I'm doing grown-up math.
Okay.
Okay, 3 root x minus 4 equals 2 root x plus 1. Oh, crap, lots going on here. Whew. Well, we have steps. That's why we have steps. So when we don't know what to do, we go to step 1. What is step 1? Isolate the radical. That means I need all the radicals together. I need everything else away. So what do you think we're going to do with this negative 4? I'm going to add him to get rid of him to the other side. Okay, so that's going to leave me 3 root x. On the other side, I have a 2 root x that I haven't touched. And I have the 1 plus 4, which is 5. Now I want all of the roots onto one side. So how am I going to move a 2 root x? Right now I'm adding it to the right-hand side. I'm going to subtract it, just like we do with regular variables. So I'm going to minus 2 root x from each side. And this is why we practice subtracting and adding. 3 root x minus 2 root x, root of x. So if I took away those root signs in the question, we did exactly what you would have done last year with linear functions. We put the x's on one side, the numbers on the other. So all we did is we put the radicals onto one side, numbers onto the other. So if you're a wordy person, radicals on one side, numbers on the other. Radicals on one side, numbers on the other. Now I'm on to step 2. How do I get rid of a square root? What's the opposite of square rooting something? So the squared cancel out the root, which leaves me x. And on the right, I heard someone say 25. Maybe that's the answer. How do we know for sure if that's the answer? We check it. We go back to the original. We take out x, we put in 25. What your brain is going to want to do sometimes is going to want to start moving this 4 to be with the 1. That's not checking, that's solving. So when you're checking, you can't move stuff from side to side. And if you think your brain might tell you to do that, sometimes it helps if you put a line in between, because it kind of stops you from moving stuff side to side. It's you work on the left, you work on the right, you hope they're the same when you get down to the bottom. What are we going to do first in 3 root 25 minus 4? The root's going to go first because it's like an exponent. So the root of 25 is 5. Then the multiplication, 3 times 5 is 15. 15 minus 4, 11. Same thing on the other side. We're going to do the root first, which is still 5. Multiplication will be 10. The addition gives us 11. We go, whew, yes, it's the same. X equals 25 is the answer. Show me a thumb so far. I'm getting this, I'm kind of getting this, I'm not really getting this. Good. Am I going too fast? Number 4. 3 plus, oh my God, I got so much going on here. There's a negative 3 under there, there's an x, a 1, I got a 7 on the other side. Yep, so again, visual peeps, sometimes it helps if you just highlight that, just so it sticks out. That's what you want by itself. That means the 3 has to go, and how do I get rid of a plus 3? Subtract 3 from each side. So on the right-hand side, 7 minus 3 is 4. Again, if you want to show the minus 3, that's fine. We're just starting to work with equations where we don't need to show every single step. The lazy people are like, yes. Been waiting years for this. How do I get rid of a square root? Square each side. And remember, if you do it to the left, you've got to do it to the right. Again, your brain sometimes will forget about the other side, but you can't just do to one side, not do the other. So that leaves our negative 3x plus 1. And on the right-hand side, we have 16. Step 3, that's just a little linear equation from last year. So how do we get rid of the plus 1? How do we get rid of the coefficient of negative 3? X equals? Maybe, maybe not. Where do we start on the left when there's so much stuff going on? So under the root, because again, there's imaginary brackets that we really should write, but we don't write because mathematicians are really kind of lazy. But we know they're there, so that's the b. And within the brackets, what do we do first? The multiplication, so the negative 3 times negative 5, negative 15. And then I'm going to do the plus 1 in the same step. Off for 16. And then I'm going to do that root next. And then I'm going to do my addition. And good to go. And most of the time, special equations are good to go, but the one we put on the exam is probably going to be one that is not, because we want to make sure you're checking. So wait for it. We're going to do an example where it doesn't work out, and I'll show you what to do. How are we feeling? You guys seem less tired today than you did yesterday. Okie doke. Oh, that's not good.
Only slightly. And believe me, with me, that's not really much of a factor. It's not really much of a factor to begin with.
How do I get rid of the plus 5? Okay. What do we have on the right? Step number 2. And be careful with the brackets here, because that negative and the 3 needs to get squared, so the whole side. If you just put a square without brackets, then you're doing negative 3 squared. So left is 2x minus 1. Right-hand side is positive 9. How do I get rid of the minus 1? How do I get rid of the coefficient of 2? Let's check it. What do we do first for our checking? Under the radical first. Again, if it helps you to put the brackets, no, that's B, put them. You don't have to put them. You can be lazy mathematicians too. What do we do first under that root? The multiplication or the subtraction? Multiplication, so 2 times 5. Then let's do it all in one step, minus 1. Then the root, so root of 9. 3 plus 5. Oh, wait, 8 equals 2? Sad face. There's a special equation. You solve it, it looks fine. You're like, 5 is an answer, but when you go to check it, does it work? That means we just cross it out.
Really?
So what is the answer to this question? There isn't one. It tells you there is absolutely no x value that will solve this equation. There is nothing we can put in for x that is going to make this whole thing equal 2. We call this an extraneous root. No, we call it an extraneous root because you sound really smart.
Yeah.
What does extraneous mean? Extra, right? The first 5 words, so it means it's extra. We don't need it. What's a root? It's the same thing as an answer, and we'll find out in Unit 3 exactly what a root means. It's the same as the answer. An extraneous root is an answer that doesn't work when we check it. An extraneous root is an answer that doesn't work when we check it. There are 4 kinds of equations you're going to run into that are like this. They're called special equations because they all have this situation is that you get an answer, you think it's all good, then you check it, it doesn't work. In Unit 7, I'll show you why it's an extraneous root and what that means is there's no solution, but for now you just need to know you cross it out. There is no x. It doesn't exist. Doesn't exist. Again, I'll show you why in Unit 7. Sometimes the book will put no solution. Same thing. No solution is the same as crossing it out. How are you feeling on the last one? By yourselves? With me? By yourselves first, then with me? Oh my God, there's 2. I think you can. Okay, so let's go to step 1. Always a good place to start when you don't know where to start. What's step 1? That just means gets a radical by itself. Is there a radical by itself? Yeah, this one's by itself, and this one's by itself. So they are actually both already isolated, just one's on each side. So let's go to step 2. What's step 2? Okay, let's see how that does. Okay, what happens on the left when we square a root? What happens on the right? Oh my God, that's like the simplest linear equation ever. X is to one side, numbers to the other, so what would you like to move where? 1 to the 3, okay. Okay. Just her 3 answers all at the same time. Fight it out.
7.
Why negative x?
Because
minus 2x. So again, if your brain needs to physically write it on top to see it, nothing wrong with that. And the other side is? How do, yes, so how do we get rid of a coefficient of -1? What your brain is going to want to do is stop here, because this is where you have stopped in every equation you have solved up until today. So you've had 4 or 5 years of equation solving, and we're like, yep, you're done. Not with a special equation. Special equation, you have to check. We go back to the original, put in our answer, hope the two sides equal, and then if we don't, we just cross it off.
Then we pretty much got nothing to lose.
Okay, so -4, -1. The square root of -5 doesn't exist. Can we do the square root of a negative? So we can't even check this. So what does that mean if we can't even check it?
It's an
Extraneous root.
Yeah.
Extraneous root.
They're both square root of -5.
But can you do the square root of -5? Doesn't exist. But it's negative. So you can't find a negative times a negative that's going to give you a negative. Can't do it. Can't do it. Extraneous root. We are done unit number 2. Do you realize that we are